Hello friends, after the classification of data structure, we are going to explain about what is abstract data type. The abstract data type is also referred as ADT in data structure. ADT is a conceptual model of information structure. It specifies the components, their structures, their relationship, and the list of operations that are allowed to be performed on the data structure. But ADT is independent of the data representation and implementation operations in the data structure. That is, we can see in the diagram, the user has the interface for the operations and properties of the data structure, but don't have any interface about the implementation part of the data structure. It is just a specification. No design or implementation information is included in ADT. The specification only involves what are the operations, but not involves that how the operations are implemented. So the definition of ADT is that it is a special kind of data type or conceptual model of data structure whose behavior is defined by set of values, properties, and set of operations, but the operations are implementation independent. That is, ADT don't have any idea about the implementation part of the data structure. We can explain one example. Suppose we take a stack ADT. We know the properties of a stack, that is, we can push any element, we can pop any element, we can check either the stack is empty or not, or any detailed functionings of the stack. But we don't know about the implementation details of ADT. We can implement a stack using 1D array or a linked list, but we don't know about these implementation details, why we are defining the ADT. So let's discuss about the next concept, that is, what is an algorithm and what are its complexity. An algorithm is a finite set of instructions or logic written in order to accomplish any certain predefined task. It is not the complete code or program, it is just the core logic or solution of a problem. This is expressed either by the pseudocode or by a diagram which is known as flowchart. We can discuss some points under algorithm and its complexity. That suppose X is an algorithm and N is the size of the input data. So the basic factors are the time and space that are used by the algorithm X, which decides the efficiency of the algorithm. So what is the time factor? The time is measured by counting the number of key of operations that comprises in an algorithm, or we can say it includes the total time to run an algorithm. What is the space factor? The space is measured by counting the maximum memory space required by the algorithm. That is, how much space or how much total space an algorithm occupies while running it. The complexity of the algorithm gives the running time or the space storage required by the algorithm in terms of N as the size of input data. How we have to decide the algorithm efficiency? So, an algorithm is said to be efficient and fast if it takes minimum number of time or less time to execute and consumes less memory space. The performance of an algorithm is measured on basis of two basic properties, that is time complexity and space complexity. In our further slides, we are going to discuss time complexity and space complexity elaborately. So, let's discuss time complexity. Time complexity of an algorithm represents the amount of time required by an algorithm to run to completion, which means that what is the total amount of time an algorithm needs to run up to its completion. So, how it is calculated? So, the time complexity is calculated by two concepts, or we can say it is taken as the execution program of sum of two concepts, that is, one is compilation time and the other is execution time. Let's discuss compile time. The time taken for compilation of the program to produce the intermediate object code or the compiler version of the program is the compile time. Secondly, the run time or execution time is the total time taken for the execution of the program with respect to number of steps it includes. So, time complexity is denoted as T of P, which is equal to C plus TP. Here C is the compile time and TP is the run time or execution time. Next, let's discuss space complexity. The space complexity of an algorithm represents the total amount of memory space required by the algorithm to run to completion. The space required by the algorithm is equal to sum of the following components: instruction space, data space, and environment space. The instruction space is the space required to store the executable version of the program. This space is fixed but varies depending upon the number of lines of code in the program. Coming to data space, it is the space required to store all the constants and variables value. And the environment space is the space required to store the environmental information needed to resume the suspended function. We can calculate the space complexity as S of P is equal to C of SP, where C is the fixed space or constant space and SP is the variable space. For example, here is an algorithm of sum of A and B. At the very first step, we can start the algorithm with start. In the second step, the value is denoted to C or assigned to C. A and B are two variables and 10 is one constant. And we end the algorithm with stop. Here we can see there are clearly three variables A, B and C, and there is one constant, that is 10. So the space complexity is the summation of the fixed space or constant space added to the variable space. So here SP is 3 variable units and 1 constant unit. So the space also depends upon the data type of the given variable and constant type, and it is added according to the space complexity. So this is the end to your slide, in which we have discussed what is ADT, what is algorithm, what are its two complexities, that is time and space complexity, and how they affect the efficiency of the algorithm. Thank you.